Welcome to the day 3 notes. I'm going to have you pause the video and work out this warm-up problem, then unpause the video and see if you did it right. Okay, so anytime that you're not given a picture, it's a good idea to draw one. So I know I'm trying to find the measurement of angle ABD if ABD and angle DBC are supplementary. So I know I want to find angle ABD. So that's an angle ABD. I don't know if it's that big or not. We're not sure. Okay, but I also need to use angle DBC. So I've already got DB, and then C can be anywhere, but since I'm using, I know the fact that they're supplementary, C has got to be this way. So my picture is going to look something like that. All right, so since we're showing all work and giving a reason for each step, we got to make sure that we're very, very specific. So the first step, measurement of angle ABD plus measurement of angle DBC equals 180 degrees. That's our definition of supplementary. That's a step that we don't typically want to write because you just kind of want to go into the next step, but since we're giving a reason for each step, we need to say why it equals 180 degrees. And anytime you have a vocab term that's given to you, you should be using the definition of that vocab term. So the next step, that's where we're going to have 18x minus 15 plus 2x minus 5 equals 180. Okay, we substituted there. We just took a value that we know and replaced it. Okay, measurement of angle ABD equals that. We just replaced. Now we're going to combine the like terms. So we've got 20x minus 20 equals 180. We added things together, but we didn't use addition for our reason because we're staying on the one side of the equal sign. We are just going to say that we simplified. All right. Next, we're going to get to 20x equals 200. We got there by adding. Okay. We use addition, subtraction, multiplication, and division if we do it to both sides of the equal sign. So to get from this step to that step, we needed to add 20 to both sides. That's why we have addition. And then our next step is going to tell us that x equals 10 by division. Okay, so we solved for x, but that's not what the question wanted us to find. We're supposed to find the measurement of angle ABD. Okay, it gives us that. Now we know what x is. We're going to use substitution again. So now we're going to say the measurement of angle ABD equals 18 times 10 minus 15. Okay, this is a substitution. Okay, so before I wrote substitute, this time I wrote substitution. They're the same thing. You can use either one. And then my last step, 18 times 10 is 180 minus 15 is going to be 165 degrees. Okay, that is by simplifying. Now, what you should do, it's not required by the problem itself, but what you should do to make sure you did it right is also plug x equals 10 in here. If I plug x equals 10 in there, 2 times 10 is 20, minus 5 is 15. 15 and 165 should add up to 180, and they do. If they don't, then you know you did something wrong and you need to fix it. All right, so today we're going to be talking about adjacent angles, linear pairs, and vertical angles. So the word adjacent means things that are next to. Okay, so adjacent angles are angles that share a side. And what I mean by they share a side, I mean I have this angle here. I'll say it's angle ABC. And then an angle here like that. So angle ABC and angle CBD are adjacent angles because they share this side. Okay. A linear pair, linear has the word line in it. A linear pair is a pair of adjacent angles that make up a supplementary angle. Okay. So adjacent angles that form a straight angle. Okay, so that's basically like the warm-up problem. those two angles were a linear pair. You had two angles that shared the same side, that when you put them together, they made a whole straight line. All right? And then vertical angles, I'm going to say they're across the X. That's a really weird way of writing it, but if you have two lines that intersect, they're going to intersect to make an X shape. The vertical angles are here and here, or similarly, here and here. Okay, so the real technical definition of vertical angles, I think, is more confusing than just visualizing an X. If you have two lines that intersect, the angles that do not have adjacent sides that are formed by those two lines are vertical angles. So in this picture, we're going to identify all of the adjacent angles, all of the linear pairs, and all of the vertical angles. We'll start with adjacent angles. Okay, there's a systematic way of doing this, and there's just a random way of doing it. I'm going to do the systematic way. So I'm going to list all of these in pairs. So angle 1 and angle 2. Now, this is different than how we've labeled angles previously, where we'd use letters. Now we're putting a number inside the interior of that angle to represent that angle. It's just another way of writing it. So angle 1 is that angle right there. All right? So angle 1 and angle 2 share that side right there. Angle 2 and angle 3 share that side. Angle 3 and angle 4. Angle 4 and angle 5. Angle 5 and angle 1. Those are all of the adjacent angles. Remember that adjacent angles that form a straight line are a linear pair. So there's going to be less linear pairs than there are adjacent angles. Okay, so I know that angle 2 and angle 3 together make up this straight line right there. I also know that angle 3 and angle 4 make up that straight line right there. Those are the only linear pairs. Okay, angle 4, angle 5, and angle 1 make up that straight line, that straight angle, but they are not a pair. They're not two angles put together. You can't say angle 4 and angle 1 are a linear pair because you are missing out on everything that's in here. So you would not get to that 180 degrees. Okay, it's got to be two adjacent angles that form a straight angle. All right, and then my vertical angles, I'm going to just highlight the two straight lines that intersect real quick. And then I can say angle 2 and angle 4 are vertical angles. Angle 3 is not a vertical angle with angle 5 or angle 1 because that angle is cut into two pieces. Maybe half, maybe a little bit off, but it's not that entire angle. So angle 3 would be a vertical angle with this entire piece if it was not for that thing right there. Okay, so now we got a little word problem. Two angles form a linear pair. The measure of one angle is 4 more than 10 times the measure of the other. Find the measure of each angle. First, draw a picture. If you have a linear pair, start by drawing a line, and then somewhere in the middle, draw another ray. You don't even have to really label the angles. You can leave them just like this, but you're going to have to know that one angle is smaller than the other. Okay? It says measure of one angle is compared to the measure of the other. The other is always going to be your x. So in this case, I know that x is the smaller angle because this is 10 more than 4 times the measure of the other. Okay, if it was like 15 less than the other, then x would be your big angle. But ultimately, it doesn't matter because this sketch does not have to be perfect. Okay, it's just a way for you to acknowledge kind of what's happening in the problem. So the other angle, 4 times the measure of that angle would have been 4x, but then 10 more is this. Since they form a linear pair, 4x plus 10 plus x has to equal 180 degrees. So 5x plus 10 is 180. So 5x equals 170 because we subtract 10 from both sides. Divide both sides by 5, you've got x equals 34 degrees. Okay, that's not our final answer. That is one of the angles. We want to find the measure of each angle. So we also have to do 4 times 34 plus 10 Okay, that's, well, 4 times 30 is 120. 4 times 4 is 16, so 136 plus 10 equals 146. Then I should take these two things and add them together. 146 plus 34 adds up to 180, so I know that I've got two numbers that will work. So the angles have measurements of 34 degrees and 146 degrees. Okay, make sure you remember the degree symbol. Make sure you write it out. If you just go like this and just put a box around 146 and 34, I'm not really entirely sure what you mean, because I wrote x equals 34 degrees here. That was technically a mistake because it was x degrees. So if x equaled 34 degrees, you're saying that angle measurement would be 34 degrees, which is not accurate. So we did the work to find these values. Our answer should be in a sentence if I give you a question that's written out in a sentence. All right. What I did here, I found 146 and then checked to adding with 34 to get to 180. That's a great way to check your work. If you just get x equals 34 and then take 180 minus 34, you'll get 146. But if 34 was wrong, you will have no way of knowing if you messed up. If you solve this out and you got like 163 or something, or 163 plus 34 does not equal 180, then you know you messed something up. And that's an easier way to check your work to see if you did things right before you move on in a test or a quiz or anything like that. It takes a little bit more time, but it's worth it to make sure you know you got both things right. All right, so next thing, line AC and line BD intersect at one point, right there. Prove that angle 1 is congruent to angle 3. This is a tough proof. This is one of the first proofs that I actually did in one of my college classes. So this isn't something that's just like super simple, but if you can understand how this is working, then life is going to be pretty easy throughout the rest of these proofs. If you're like, I kind of understand it, you're ahead of the game. And if you're looking at it like I have no idea what's going on, then you might want to remember what some of these vocab terms are going to be. So normally we say what our given information is. So I'm going to start with statements on the left and reasons on the right. If I can spell reasons, that'd be even better. It would make a little T-chart. That's what we usually do. So statements, number 1, we basically just rewrite what the question says. Line AC and line BD intersect at one point. And our reason for that is it is given to us. The prove that piece, that's going to be the last statement. The last statement is angle 1 is congruent to angle 3. Okay, but what we need to do right away is look at things related to angle 1 and angle 3. We cannot just jump to this and say angle 1 is congruent to angle 3 and then come up with a reason why. If we're trying to prove it, we have to show an explanation of the entire process. So I could start with angle 1 and angle 2 are a linear pair. And I could also, in that same step, since it's going to be the same reason, I could say angle 2 and angle 3 are a linear pair. And the reason I can say that is it's the definition of a linear pair. Right? We have two angles that are adjacent. Okay, angle 1 and angle 2 have this ray together. Angle 2 and angle 3 have this angle together, that ray together. They're adjacent and they form a straight line. They form a straight angle. We know that it's a straight line because we are told that these are two lines that intersect. All right, so if they are a linear pair, then the measurement of angle 1 plus the measurement of angle 2 equals 180. And the measurement of angle 2 plus the measurement of angle 3 equals 180. Okay. This is technically the linear pair postulate. this is one that I don't usually get too picky on. We shouldn't use the definition of linear pair. Again, you don't use the definition of the same thing twice in a row to show two different things. But basically, I need to know that linear pair is 180 degrees. If you say linear pair postulate, that's probably the best case scenario. Linear pair postulate says linear pair has angles that sum up to 180 degrees. Okay, now if these two things are equal to the same thing, that means they are going to be equal to each other. Oops, just the measurement sign there. Sorry about that. And that is just substitution. Okay, you can use substitution, or you could use the transitive property. Either one is okay in this case. The reason why either one is okay is because this is an equal sign. Substitution works with an equal sign, but it does not work with a congruent sign. Transitive property works with an equal sign, and it also works with a congruent sign. So either one, realistically, transitive is probably the better option, but substitution works just fine as well. Now, step 5, I'm going to get measurement of angle 1 equals measurement of angle 3 by subtraction. You might be thinking, what did I subtract? I subtracted measurement of angle 2 from both sides. You don't have to write the measurement of angle 2 part that I just wrote, the minus measurement of angle 2 minus measurement of angle 2. But that's what we did. So now if two measurements are equal, that means the angles are congruent. Anytime you're going between equal to congruent or congruent to equals, that is the definition of congruent. So what we just showed is that those two angles are congruent. You could use the exact same reasoning and just change these numbers, the 1s, 2s, and 3s, to show that angle 2 and angle 4 are congruent. All right? So what we just proved is that vertical angles are always congruent. You will never have to write out this full proof again if you can remember that vertical angles are always congruent. If you cannot remember that, then you have to go through these steps anytime you want to use vertical angles being congruent in a proof. I recommend that you remember that vertical angles are always congruent because that is a very, very important and powerful step that you can use in a lot of proofs. So, complementary angles can be vertical angles, always, sometimes, or never. So complementary, you have to remember what these things actually mean. Complementary means they add up to 90 degrees, but I don't care where the angles are. So can they be vertical angles? Yes, they can be. But are they always, sometimes, or never? Well, I said they can be, so they won't be never in this case. But are they always? Well, in order to be vertical angles, we just showed they have to be congruent. So the only way you can have two angles that are the same add up to 90 degrees is if they are 45 degrees. And you can have complementary angles that are not 45 degrees. So this one is sometimes. Adjacent angles can be vertical angles. This one's never. Okay, vertical angles do not have an adjacent or a side in common, I should say. They don't share that same side. Okay, so they can't be adjacent angles and be vertical at the same time. Vertical angles are supplementary. This kind of is almost the same question as this one, okay, except for instead of complementary being added up to 90, we're doing supplementary, so adding up to 180. So vertical angles can add up to 180 if they are both 90 degrees. So that would be sometimes. Linear pairs are complementary. That one will be never because they always have to form a straight line. That's why they're called linear pairs. Okay, linear pairs are adjacent. That's like right in the definition. Adjacent angles that form a straight angle. Complementary angles always have a second point. I said second point, sorry about that. Complementary angles always have a common point, sometimes have a common point, or never have a common point. This one is also going to be sometimes. They can, but they do not have to. All right, so for this one, we're going to kind of apply some of these things. We want to find the measurement of angle ABD. Okay, it's not a bad idea if you want to get in the habit of maybe highlighting the angles you're trying to find. And we also want to find the measurement of angle DBE. And what types of angles are these two? So I'm going to answer that question first. Okay, those two angles are going to be a few different answers. You could say they're complementary, and you can say they are adjacent. I know they're complementary because I'm kind of getting ahead of the game, but if angle EBC is 90 degrees, we have a straight angle ABC that tells me that ABE also has to be 90 degrees. So if I were to do the entire full process, I would have measurement of angle ABD plus measurement of angle DBE plus measurement of angle EBC equals 180 degrees. The only thing you can tell for sure is that that is a straight line. Okay, and then I'm going to substitute those values in. All right, I know that was 90 because of that right angle right there. So if I combine my like terms and then subtract, this is how I know for sure that they are also complementary. Divide both sides by 5. I've got x equals 18. That is not my degrees. I plug it into each piece. Okay, so 3 times 18, well, 3 times 10 is 30. 3 times 8 is 50, so we get 54. And then this should be 36, 2 times 18. So the measurement of angle ABD equals 54 degrees. Measurement of angle DBE equals 36 degrees is our final answer. So, what did we go through in this lesson? What things are not 100% clear to you? This is a great place to write stuff down so that when we have class in person, you can look back quick and see, did I have questions, and ask them, or if you want to send me an email as you're working through homework, and this is the type of questions you may or may not have. I hope everybody has a fantastic day.